Thank you for coming. Glad you're here. We're here at the beautiful Harold J. Miyasi Cultural and Performing Arts Center at Cuesta College. We're here on Saturday evening on Martin Luther King weekend to celebrate the first keynote presentation of the Morro Bay Winter Bird Festival. Yay, Morro Bay. This is our first event here. And we're here in part because of many of you. Anybody who's a regular attendee of the Morro Bay Winter Bird Festival knows that we always ask you to fill out your evaluation forms, almost as often as we remind you to wear your name tags. And we read every evaluation form, and your constructive criticism, gentle suggestions, and positive feedback drive the changes that we make for the festival. And about 2 years ago, you told us that we needed to find a bigger and more accessible venue for our evening presentations. And here we are. What do you think? So we're excited about that tonight, and then we'll see you right back here tomorrow at 7 o'clock for Christina Schief. Going to be another great presentation. Along the lines of evaluations, which we hope you'll fill out again this year, and your name tags, which get you into special places, we do like to reuse our name tags and our lanyards. You can keep the tag that has your name on it. That's yours to keep. But we really appreciate it if you return the lanyard and the holder so that we can reuse them year after year and conserve resources. So you can hand these in anytime up until noon on Monday when the community center closes. You just hand them in at registration. The rest of Monday afternoon, you can hand them in at the Inn at Morro Bay, because one of our last events is the Mind Walk presentation, which will be at the Inn at Morro Bay. It's about the oyster catcher research. Should be good. So you can hand them in there. If you get home and Tuesday you realize you've got lanyards from every Morro Bay Winter Bird Festival you've ever attended, and they just go in the same drawer, feel free to stick them in an envelope and send them to us at our P.O. box, and we'll reuse them year after year. So thank you for that. As a reminder, this event is entirely volunteer-driven. We don't hire some big fancy somebody to create a festival for us. Our board of directors meets monthly to put on various aspects and plan various aspects of the event. All of our leaders are volunteer. Yeah. Woohoo! Thank you, leaders. You share your time, your knowledge, your resources, your years of experience with all of us to create an amazing educational experience for everyone involved, and we really are grateful for that. It couldn't happen without your generosity. We also have about 80 volunteers who show up for this weekend to do various tasks. So when you combine everybody together, it takes a village to put on a bird festival. We also have various committees that are on the board who are involved with various aspects of the festival. I'm the board chair, Michelle Roost, and on behalf of our board, I welcome you. Thank you. And then we have the program committee. The program committee is responsible for putting together more than 140 presentations, field trips, workshops, and special events that we all get to learn from throughout the weekend. It takes them a whole year to put it together. And this year we have a new program committee chair. Susie Black did it for 8 years. She's moved on to a calmer, simpler life. And this year, Chris Cameron is the chair of the program committee. The program committee is also responsible for finding keynote speakers for our evening presentations. So I'd like Chris to come up and introduce our evening speaker for tonight. Thank you all for being here. Have a great evening.
We walked quietly to the pepper tree, and as we slowly approached it, he pointed out, see those small holes? Those are xylem sap holes. And those larger holes, those are phloem sap holes. And those are important for the sap-sucking woodpeckers who have this little brushy tongue. And they make a hole, and then they go to another tree, and they do this circuit, and they come back, and they lick with their brushy tongue the sap from those holes. And that's the first thing that I learned from Steve Shunk. It's actually the only thing I've learned from Steve Shunk, because I only spent about 5 minutes with him the other day when I picked him up. So that's why I'm here, to hear if there's anything else that's worthwhile to learn about woodpeckers today. Steve Shunk, our speaker, I'll introduce him in just a little bit, but he does have some books. He's the woodpecker guy, and he's actually written the woodpecker book, the Peterson Field Guide to Woodpeckers, and he's only got 12 left. And they'll probably be sold in the first 5 minutes after the show. But I just said, what will you do after the show? He says, if you send him an email, he will sign a book, and he will mail it, postage paid, to you. So if you want a book, Steve will make sure that you get one. And the more books you buy from our speakers, the more money they make, the more chance they have to come and do something like this. So support our speakers and buy their books. A couple of housekeeping things is, thank you, Steve. A couple of housekeeping things. There's still people coming in. If there's a space or two in the middle, if you could scoot maybe one seat over to the middle and leave an edge seat so people can sneak in and not have to crawl over everybody to get there, that would be helpful. There are some really expensive seats right here if you really want that full experience. It's right here in the front with Richard and his crew. Yesterday, Jeff Miller, Jeff, I saw you someplace. Jeff, where are you? Wave your hand. Jeff is in the back. Jeff was out owling, and he lent his binoculars to somebody, and he can't remember who he lent them to. So if you have Jeff Miller's binoculars, please get them to him. So that's a little bit of the housekeeping that I think is important. Next year's keynote speaker, one of them is already here because he was supposed to be here this year, and then he ended up on the other end of the world doing some bird thing. But he posted on Facebook. He says, Costa Rica's great. And I said, so is Morro Bay. You coming next year? And he said, oh, yeah, I am. I said, keynote next year? He said, yes, absolutely. So Ray Van Buskirk is our keynote speaker for Saturday night next year. I will tell him you applauded. That'll make him feel better. And so we haven't got our Sunday night speaker, so if you got suggestions for great speakers, email them to me, somehow get me a note, and we got a list. Our committee will evaluate and run through them. Okay, so Steve Shunk was raised with a deep love and respect for nature. He studied meteorology and environmental studies at San Jose University. He began birding in the Bay Area in 1989, and get this, only 3 years later, he started teaching birding classes. So he's like a quick study, sharp on the uptake there. He moved to Central Oregon in 1997, and then he founded the Paradise Birding Tour Company. This is less than 10 years after he started birding. And now he's an accomplished and professional naturalist. He leads birding and natural history tours throughout the Americas, as well as destinations in Asia and Europe. Now let's go back to Oregon for a second. In Oregon, Steve co-founded the East Cascades Bird Conservancy, which is now the East Cascades Audubon Society, and he was the first president. He co-founded the Oregon, yay for the East Cascades Audubon Society. He co-founded the Oregon Birding Trails program and coordinated the flagship project, the Oregon Cascades Birding Trail. I don't know anything about that, but just that name makes me want to go explore birds in Oregon. He served 15 years as a compiler for a couple of two Christmas bird counts. He's worked as a field biologist on and off for over 20 years, and he recently conducted blackback woodpecker surveys for the Institute for Bird Populations in California Sierras, Nevadas, and Cascade Mountains. Now, he's been recognized, he's recognized the amazing variety of woodpecker diversity on the eastern slope of the Oregon Cascades, where 11 species will annually nest and raise their young. So he began studying the woodpeckers across the continent. And since he's done that, he's now founded the Woodpecker Wonderland Festival in Camp Sherman, Oregon in 2008. So as a result of all this research that he's done on woodpeckers, it culminated with a publication of his Peterson Reference Guide to Woodpeckers of North America in 2016, a book which 12 people will get here tonight, and the rest of you will write him a note, and it will be emailed to you, it will be mailed to you soon. So Steve, come on up. Thank you for being our keynote speaker.
Thanks, Chris. You guys hear me okay in the back? I also want to, a special thanks to Chris for being my main liaison to the event. He was great, stayed in great communication with me, and has helped make sure that everything has gone perfectly smoothly for me. So I want to especially thank him. But I also want to thank Michelle and Kelly and the whole board for inviting me to the event. I am truly honored to be here, and you are officially my largest audience ever. And it's good that they turn the house lights down a little bit, because it's a little intimidating. But so we're going to talk about woodpeckers tonight. Okay? I love talking about woodpeckers, and it's going to be hard to, it's hard to encapsulate it. And I could teach a weekend-long or a week-long woodpecker seminar for you if you really wanted it. And we do that, actually, up in Central Oregon in the summers. But tonight, I'm going to do a special talk for you. I'm not really here to do big advertising, but Chris did mention the book. This was an incredible project, and I've never really done anything like that. I never graduated from college, so this was. Thank you. So I imagine that this might have been something like a dissertation for those of you that have done it. My dad's dissertation was about as thick as this book. So anyway, and as Chris said, if you aren't able to get one of there actually are 10 books left now, I think. If you're not able to get one of those 10 books, I definitely will send you one, okay? And you just email me, steve@paradisebirding.com. There are little rack cards with my email address up at the table in the back, and you're encouraged to take one of those and get in touch with me, and I will send you the book, and I will pay the postage, okay? That way you get a signed copy. You can order one on Amazon, but it's not signed. If you're interested in any of the trips that we lead, you just go to paradisebirding.com. I'm also proud to say that I'm now doing some guiding for Naturalist Journeys. They've been around for a while, and they have a great reputation, and I'm really honored to be working with Peg Abbott and the whole crew there. So I've got 3 trips this year with Naturalist Journeys and several for 2021. Okay, let's talk about woodpeckers. It is generally agreeable to be in the company of individuals who are naturally animated and pleasant. For this reason, nothing can be more gratifying than the society of woodpeckers in the forests. It's a pretty bold statement for such a great naturalist, and I think that you can agree that woodpeckers are special, and they really captivate us. And they are charismatic, and they're dynamic, and they're resourceful, and they really do capture our attention when we're out there birding. They're easy to see often easy to find. They're not like little warblers popping around in the tree. And so, anyway, woodpeckers are special, and they have definitely captured my attention. And so tonight we're going to talk about how woodpeckers can save the world. Okay? Woodpeckers, how woodpeckers can save the world. I mean, you'll get the whole thing down. So I'm going to cover kind of three main areas: natural history, ecology, and conservation. I'll go through each of these. I'll talk a little bit in the natural history section. I'll talk a little bit about woodpecker anatomy, which is a complete presentation on its own. So we'll just be able to scratch the surface with that tonight. And we're going to start with natural history, a day in the life of a woodpecker. This is a nestling female hairy. You can see she's got just a tiny bit of red in her crown. And the males would have quite a large patch of red there. Not all female hairy nestlings have red, but this is a good example of one that has a minimal amount. Okay, so natural history, to me, is a challenging term. Whenever we hear the word history, we think of the past. But natural history is really the story of how these organisms live and how they do their thing day to day, day in the life of a woodpecker. That's its natural history. And so we're going to start with what woodpeckers eat. Woodpeckers, we kind of think of woodpeckers as just pecking on wood and eating insects, but they do have quite a diverse diet, not quite as diverse as shown here, but they do have a diverse diet. And the traditional kind of diet for a woodpecker is something like what this blackback woodpecker is doing here. He's excavating into the wood of the tree, past the cambium, for one of those wood-boring beetle larvae. There he goes. Let's just see that one more time. This is a male. Got a yellow crown, and this is not sped up. That's the real speed, and he just gets right in there and pulls that grub out. So that's kind of what we typically think of when we think of woodpeckers feeding, but we have to remember there is quite a bit of diversity in the woodpecker family, and the sapsuckers are definitely woodpeckers, and sapsuckers eat sap. Very good. And they are adapted for eating sap. Okay, and I'll talk a little more about that in a minute. It goes even beyond that, though. The Lewis's woodpecker, just like the acorn woodpecker, is a fly-catching woodpecker. Okay, this is an example of a Lewis who saw a flying insect from that distance and swooped up to catch that insect. And the Lewis's are quite adept, and it's really fascinating to watch them catching insects. It's even more fascinating to watch them when they're courting and defending territory and they're chasing each other around. At this spot right here is a great place to do that at Shevlin Park in Bend. But as is the case with most of that genus of woodpeckers, the Melanerpes genus, Lewis's also have a really broad diet. And so this one's taking currants, ripe currants, to the nest to feed its nestlings. So the timing is perfect for them to nest right when those currants are ripe. And those currants are pretty tasty, by the way. And of course, another part of the diversity of woodpecker diet is you all are very well aware of the acorn woodpeckers and their penchant for storing and eating the meat of acorns. Okay? So diverse diets from insect to sap to from wood-boring insects to sap to flying insects to fruits and nut meats. Depending on the genus and the species of birds, they have quite a diversity. Okay, do woodpeckers migrate? Do they? Most woodpeckers are sedentary. Does that mean they sit on the couch all day? Now, what does that mean? They're non-migratory, right? So most woodpeckers are non-migratory, and that goes for the whole world. There are about 220 species of woodpeckers in the subfamily that we think of as kind of the true woodpeckers, and very few of them migrate. It just so happens in North America we have several that migrate, but let me start with non-migratory woodpeckers. So this is the kind of map that you might see for the hairy woodpecker. And this is year-round territory for these birds. They don't migrate. They rarely even have an elevational migration. Some high altitude woodpeckers will come down slope in the winter, but Harries stick around throughout their home ranges throughout the year. So they breed all the way up into central Alaska, and as you get down into Mexico and towards Central America, we get into some different subspecies of Harries. So the main part of the US and Canada are the Harries that we're most familiar with. Then we have kind of, before we talk about the true migratory woodpeckers, we have this interesting bird, the acorn woodpecker. Not migratory, okay? Those areas that are red there are the general year-round range for the acorns. But if you see these little dots all over here, these are all what we call extraliminal records for acorn woodpeckers. Okay, so they don't migrate, but acorn woodpeckers are considered a pioneering species. And some of you may be familiar that they live in family groups. Okay, so in any family group of acorn woodpeckers, there's the mated pair, who are the parents of all the other individuals in that family group. Okay, it's one family. And so those are the siblings and the offspring of that one mated pair that stick together. But if those siblings and offspring, if they're going to breed, they have to pioneer out, and they have to go look for a new territory on their own. So what happens is the birds will seriously pioneer, and they will cross large areas of land looking for suitable habitat. And they have a number of different things they need in a healthy habitat for them, and they just keep going and looking for these different places where they can thrive. So they need acorns, they need open habitat because their primary food. Anybody know their primary food? Acorns? No, it's not acorns. And their scientific name is formicivorous. Anybody know what that means? Ant-eating. That's not their primary food either. Flying insects, very good. Year-round, the favorite food of acorn woodpeckers is aerial insects. And just like that Lewis's woodpecker, the acorns are quite adept at feeding on those aerial insects. So they need open habitat that has an abundance of aerial insects. They need oaks. They're eating acorns mostly in late summer and early fall when the acorns are ripe. And they also need snags, or trees that have rotted so that they can excavate those trees for their nest cavities. So they will spend quite a bit of time and travel quite a distance to look for those habitats. So as for migratory woodpeckers, the Lewis is fairly migratory. We have some year-round territories down here in the south and some in California. These birds breed and overwinter in those same habitats, and the northern birds up here in the blue areas migrate down as far sometimes as this red line, but that's kind of the extent of the range. Now, these guys also will end up in interesting places, and I believe there's even a record for Newfoundland of Lewis's woodpecker. But it's not a long-distance migrant. We wouldn't consider that. It's not a neotropical migrant going down into the tropics. It's just kind of a short-distance migrant with several year-round populations that don't move in the seasons. The next one that's migratory is the northern flicker. This happens to be an intergrade, a yellow-shafted, red-shafted intergrade. If you can see this little bit of red here, that's actually a little part of the nape. It comes around the back. That's a trait it's picked up from its yellow-shafted parentage. And you can see from the map here that we have breeding populations in the far north, all the way to western Alaska, and all the way over to the maritime provinces. Then we have overwintering territories here in the orange, and then year-round territories here. So these birds up here probably go quite a ways down south. These birds in the middle tend to stick around and not be so migratory. But I'm sure you notice in the winter you have a large influx of flickers. And you actually then also get a large influx of these intergrade flickers in the winter, because the intergrade zone kind of starts up here near the Yukon Territory and goes down to the Texas Panhandle. So everybody to the east of this line is mostly yellow-shafted. Everybody to the west of that line is mostly red-shafted, but those two intergrade across a wide swath. Then all the intergrades in BC and parts of Alberta will migrate south down into California for the winter. So keep your eyes on your flickers. So not only do we have several migratory woodpeckers in North America, but we have the world's most migratory woodpecker. And you happen to have, I think, a couple of these yellow-bellied sapsuckers around here right now. And this bird migrates farther than any woodpecker in the world. They have a long-distance neotropical migration. They breed all the way up into eastern Alaska and migrate as far as Panama. And we even have a few records of yellow-bellied sapsucker for Colombia. The Caribbean is loaded with yellow-bellied sapsuckers in the winter. Anybody who's ever been birding in the Caribbean in the winter has very likely seen one, or you've at least seen the signs of a yellow-bellied sapsucker, just like Chris was mentioning those xylem wells or the phloem wells, the rings around the tree of their little holes where they're feeding on sap. Okay, got the migration part down. Do woodpeckers sing? What do you think? I'm hearing mixed answers. Woodpeckers certainly vocalize, right? We hear them vocalize regularly, okay? And their vocalizations, though, are pretty simple, straightforward, and single notes sometimes. Sometimes they give a rattle. It's like a hairy woodpecker will do a single note that's like a kick, and then kick, 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 kick. You'll hear the flicker do similar sounds. Those are their general types of vocalizations, but we also have some fun vocalizations that the flickers do when they're courting or defending territory. This is the sound that they're making here. I ran across these guys in Philadelphia. Then the real signature sound that comes from a woodpecker, though, is their drumming. Okay? And drumming is the woodpecker's equivalent of singing. So this is a three-toed woodpecker here that's drumming on a snag in our region up in Central Oregon. This is the equivalent of singing. So though they vocalize, they don't really do any other kinds of, most of their vocalizations are just communication among their individuals. Okay? What about nesting? Do woodpeckers make a nest like this raven? No, they don't, do they? Probably the most classic woodpecker behavior of all, beyond everything else we've talked about, is the excavation of the nest cavity. I'll spend a little extra time on that tonight because it's such a fabulous thing that they do. And it's just kind of hard to imagine how this evolved and how they can be so good at this practice. So a nest always starts with what we call starts. Okay? So this is an aspen tree that has several starts in it. And these happen to be sapsucker starts. And what will happen is one bird will come and make several starts and then go up to the top of the tree and drum and call and bring its mate in. And then the mate will go down with the first individual and they'll inspect the starts. And then oftentimes it's that mate that was drawn in that will choose the one that they're going to excavate as the nest cavity. Okay, and you can see right here is the actual nest cavity, and these are all starts down here. And they may go in and excavate those in the winter for a roost site, or they may use them as a nest site in the future, but the starts don't really serve any purpose beyond the time when they've started excavating their nests. Okay, so we start with starts. That's easy to remember. Okay, then we have to get into the tree. So we have to we've already gotten past the outside of the tree, and we have to get inside there. And this is actually a hybrid sapsucker here, not a red-breasted. But so you can see that this bird has chipped away a little bit of wood and is tossing it out. Okay, pretty animated. I mean, how can you not love watching this? I mean, you could come and look at this. Watch this. Watch this. This bird is backing out of the cavity. Can you imagine the feather wear? Fabulous behavior. Fabulous. Here, once you've gotten that cavity constructed inside, then you can go all the way in and bring wood chips out and toss them out like such. It's really hard to appreciate this unless you can see a cutaway of a woodpecker cavity. This friend of a friend had to cut a tree down in his yard, and the red-breasted sapsuckers had nested in there that prior year. So he sliced the log in half and gave this to me. And this gives you a great idea. And remember, they start with nothing. They start on the outside of the tree, and then they're going in, throwing out some wood chips, going in deeper and a little deeper. And only when they get this bottom section kind of expanded can they go all the way in, turn around, and finish excavating. Okay, amazing behavior. And to me, it's also amazing how they can make such a perfect circle for the entrance. Well, a circle is the most efficient shape to make. If you have to make a shape that you're going to enter and exit from, you need to make it efficient, and you need to make it so that a minimal number of predators can enter that nest cavity. And there are very few predators that can enter a nest cavity. Okay, so we've got the cavity made. We leave some wood chips in the bottom. We don't carry nesting material in. All right, so we leave some wood chips in the bottom as a little bed, lay our eggs in there, and then our eggs hatch, and then we're feeding our young. So when the young are very small, the adults can go all the way in the nest. The female just went in. Here is the male. He's got a couple of wood-boring beetle larvae. He can't fit in there while she's in there, so he chats with her a little, and she leaves. He goes in and then sits for a while and then carries out a little fecal sac. Okay, those young, they will poop in these nice, neat little bags called fecal sacs. And the adults, and primarily the male, some people like to hear that, primarily the male does the nest sanitation. And then as the babies get older, then they start smushing up those fecal sacs, and it gets kind of messy. But remember, there are wood chips in the bottom, and those wood chips help absorb the fecal material. So sometimes you'll see a woodpecker come out of a cavity carrying what looks like a messy glob of wood chips, and that's exactly what it is. Okay? So, but once the young get older, the adults can't go in the cavity all the way. So then they'll feed kind of halfway. This is a pair of what I call reddish sapsuckers, because this first bird is a hybrid, and the second bird is a leucistic red-breasted sapsucker that's bred for the last couple years in the sisters area. So we'll watch that one more time. Again, the young are big, and so the adults have a harder time getting into the cavity, and they feed them from the entrance. When it gets near the time when the young are about to fledge, then the babies get fed right from the cavity entrance. This is a nestling Lewis's woodpecker calling for its parents, and the Lewis's has been out collecting insects and comes and delivers the food right there at the cavity entrance. Okay? That's the nesting cycle. So this behavior is fascinating and hard to imagine how it evolved. And it requires some very specialized anatomy. So what is it that makes a woodpecker able to do that? The first part of that is for you to understand exactly what's happening when a woodpecker hammers its head against a tree. Okay, so this is a little bit of a lesson. What does this look like? Good. Good job. That's a brick wall. This looks like my head, but I want you to picture it as your head, okay? And in order for you to hit your head against, in order for you to exert the same amount of force that a woodpecker does when he hits his head on a tree, you would have to hit your head on a brick wall going 16 miles per hour, exerting 1,200 Gs of force. Okay, humans can barely withstand 10 Gs. But woodpeckers can deliver blows at 1,200 Gs of force and then redistribute the resultant forces back through their anatomy without causing detrimental harm to their soft tissues. And again, I could talk for hours about anatomy, so I'm just going to kind of go quickly through some of the highlights. How is it that they don't get headaches? The first thing to know is that woodpeckers have almost no cerebrospinal fluid in their cranial cavity. Humans have a lot of cerebrospinal fluid, and this is why we get concussions so easily. Our brains slosh around in a bath of that fluid, and they smash up against our frontal bone and back against our occipital bone, causing us to have concussions. Woodpeckers' brains sit very tightly inside their cranial cavity and can't move forward when they're excavating. Also, inside the cranium, we have these specialized bony areas. Inside the frontal bone and the occipital bone are these networks of bony fibers. And they're incredibly fine little fibers and very dense. And they're designed to disperse force. Okay? And so if it were a solid piece of bone, the direct forces would be too much for them to withstand. Instead, they have this, people sometimes call it spongy, but it's not really spongy like a sponge. It's more of a fibrous web, kind of, a 3D web of bony fibers. So the frontal bone is larger because of the first delivery of those blows, and then what happens when you hammer is you get a resulting force going backward. So to protect the rear part, the occiput of the brain, the occipital bone also has that bony fiber. Several woodpeckers have what we call a frontal overhang. This is the most prominent in the woodpeckers that do the most hammering. So when we look at the skulls of the woodpeckers, we see quite a bit of specialization in the different genera and the different species. And in particular, I want you to look at the sapsucker here and Nuttall's, downy, and white-headed. Do you see the little shadowed portion here? Okay, that's the frontal overhang. It's a special bone that bulges out over the bill. When the woodpecker hammers its head against a tree, there's a special hinge called the nasofrontal hinge that's loose. The frontal overhang helps then direct the forces downward, away from the cranial cavity. So the blow goes against the tree, the resultant forces go down away from the soft tissues to protect the brain and the eyes in particular. The birds that do less excavating, Lewis is red-bellied, and this is an imperial woodpecker, but very similar to the pileated and the ivory-billed woodpecker, with no frontal overhang to speak of. Notice also the nares, or the nasal openings, of the heavy-duty excavators here in the middle versus those of the weaker excavators. Okay, they're elongated and off to the side. Why would that be? When you're hammering against wood, what's going to happen? Wood chips are going to fly back in your face, right? So they have special eye protection to protect their eyes, and their nasal openings are off to the side and narrow to help prevent wood chips and dust from getting into their nasal openings. Fascinating. And there are several other skeletal features I'll point out. I'm going to talk about the tongue up here in a second. There are special ribs. Especially the birds that do the most excavating, they have these specialized ribs that have strong muscles attached to them that go all the way up to the neck that allow them to deliver the blows, and then those muscles send the resulting forces downward into the torso, again to protect the soft tissues of the head. Woodpeckers have a shallow keel, which helps them get closer to the tree surface when they're climbing. Okay? A big keel is in a bird like the waterfowl. Okay, so that they can have large flight muscles attached to the keel that go out to their wings for long-distance migration, and because they tend to be heavy birds, they need to be able to get aloft. Woodpeckers are generally not big flyers. We have a couple of migratory ones that we talked about earlier, but in general, they're not big flyers, so they don't need that big keel. Down here at the bottom is another really important part of the anatomy that we're going to talk about again in a second. This is called the pygostyle. It's a set of fused bones at the base of the backbone, and the larger pygostyle occurs in those woodpeckers that do more heavy-duty excavating. What's the purpose of a large pygostyle? Well, remember, a large keel is for attaching large muscles, right? Well, if you're in the vertical plane most of your life, you're using your tail as a prop against the tree so that you can get the leverage needed to rear back and deliver 1,200 Gs of force. In order for you to be able to hold your tail against the tree, you have to have extra strong muscles, and those muscles need a larger surface to which they would attach. So the pygostyle is the pygostyle has become the base for those muscles that hold those tail feathers. Back to the tongue. Woodpecker tongue has fascinated scientists for centuries. in the book, I've got a picture from 1630s, I think, by Borelli, who was a contemporary of Leonardo da Vinci. Da Vinci was the first one that we know about who wrote about the woodpecker tongue. Borelli was the first one who sketched it. And since then, we've learned a lot more, obviously. That was in the study of comparative anatomy. And now we've delved deeper into the woodpecker anatomy, and we've learned so much about this amazing tongue apparatus. It's not just a tongue, it's what we call the hyoid apparatus. We have a hyoid bone, just one bone in our throats that helps us extend and retract our tongue. And it's the only bone in our body that does not have a joint. It's not attached to other bones. The woodpeckers, though, have these very specialized feeding behaviors that require something else, and it's more than just a hyoid bone, it's an apparatus. So this generally shows the bony parts of the tongue. So starting here at the tip, there's a fleshy part attached to this. I'll show you in a minute. It starts as a single set of bones, fused here at the tip, then a bone here, then there's a set of fused bones right here behind the jaw. Then the hyoid bones split into an elongated Y shape. They go around the esophagus and the backbone. Then they come back up around the back of the head and follow each other parallel and generally end toward the right orbital socket. Every time a woodpecker sticks its tongue out, that whole thing unwinds and rewinds. Okay, and it can do that many times a second. The flicker's tongue is the longest of all our woodpeckers. His doesn't stop at the orbital socket, okay? It goes past the orbital socket into the right nasal opening and into the upper mandible. So when a flicker's at rest, both the tip and the terminal ends of its tongue are inside its bill structure. That makes my nose hurt every time I talk about it. Now, don't be scared. I'm going to show you a schematic here. This is in the book in case you want to study it. This is just an example of how complex the hyoid apparatus is of the woodpeckers. Specialized bones and muscles designed for extending, retracting the tongue, and for wiggling the tip of the tongue once they get it to look for their prey items. Very specialized apparatus. So that's just the hyoid apparatus. Then we have, as I mentioned before, the fleshy part of the tongue, just like our fleshy part. We'll start with the flicker. The flicker's favorite food is ants, and underground ants are preferred. The flicker also has a very large submaxillary salivary gland. The maxilla is the upper mandible, and when the tongue extends, it goes past that salivary gland and gets coated with sticky saliva, and it's got this rough, like sandpapery section, which actually is a bunch of little tiny bumps. They're made of keratin. And the saliva sticks to that, and it increases the attachability, for lack of a better term, of the tongue. It goes into the ant burrow underground, and the ants get stuck to that surface. And then it withdraws its tongue and is able to get the ants off. So the little sandpapery stuff creates a frictional surface that helps hold the saliva on there that allows them to get their ants out of the ground. Then we have an acorn woodpecker, which is very similar to the red-headed and the Lewis's. These guys, their favorite feeding behavior is catching aerial insects. Good. And so they have this kind of messy set of little barbs at the tip of the tongue and a relatively large tongue with a fairly narrow section of those sandpapery bumps. And this tongue is designed for pulling in aerial insects. So when you open your mouth, you've got an insect, and it allows you to extend the tongue to catch the bug. And then the thickness of the tongue allows you to hold the insect in your lower mandible while you open your bill to catch another insect. Okay? Very specialized for its feeding behavior. The blackback woodpecker's favorite food, anybody know what it is? I showed you earlier. Wood-boring beetle larvae, wood borers. The three-toed woodpecker's favorite food is bark beetle larvae. The blackback, though, is a specialized excavator, and he actually is probably the heaviest duty excavator in the world. Okay? Most woodpeckers are in the tropics, and they're feeding on soft woods. The blackback woodpecker, 95% of its diet is wood-boring beetle larvae. Okay? Year-round. non-migratory bird feeding year-round in these trees that have these larvae in them, grubs, as we sometimes call them. So, specialized tongue. The tip of the tongue is quite narrow, and the barbs at the tip are backwards pointing like a fishhook. Okay, the blackback woodpecker sticks its tongue into a larval gallery, which is basically a tunnel that's been chewed away by the larva, sticks the tongue in between the larva and the wall of the gallery, and pulls back. And those backwards-facing barbs get purchase on the skin of the larva and pull it back out of its gallery. Okay? And then, as Chris mentioned earlier, the sapsucker tongue. So I get one of the most common questions I get when I'm talking about woodpeckers is, do sapsuckers make sap wells for the insects that come to the sap? Well, the insects certainly do come to the sap. The sapsuckers are actually providing food for all these invertebrates that come and feed on the sap. But we know the sapsuckers are adapted primarily for eating sap. The way we know this is because of the shape of the tip of their tongue. So look at the tip of that tongue. It's got those same kind of little protuberances, those little hairy-like things, except they don't point backward. They point outward all around the tip, just like a little brush. So when a sapsucker excavates a sap well, it takes its tongue and swooshes it around that sap well to collect sap, just like you would use a paintbrush to collect paint. Okay? All right, let's move to some external anatomy, talk about feet. In general, we have heard over the years that woodpeckers have this zygodactyl toe formation, which is toes 2 and 3 forward and toes 1 and 4 back. The problem with this is that this is a perching adaptation, not a climbing adaptation. So the true zygodactyl foot really only exists in the flickers and some of the Melanerpes woodpeckers. The flickers spend most of their time where? On the ground. So and when you see them on a tree, they more often will perch on a branch than they will perch or land vertically on the trunk. Okay? Their feet are better designed for grabbing. But for these birds that are climbing, that wouldn't do any good. If you're a rock climber, think about this for a second. You tend to have your fingers, your hands grabbing this way, and we tend to have more or less a 90-degree arc where we mostly do our holding when we're climbing. Do we hold underneath here? Not generally. Sometimes you have to, but in general, that's not advantageous for opposing gravity, right? If you're going to oppose gravity, you need to be up here somewhere. So for the woodpeckers that spend more time climbing, they have a specialized toe arrangement called ectropodactyl. That means outer movable toe. Okay, so this toe here, the long number 4, can swing around so that it's out here on the side. So you've got your 2 toes forward, 1 out to the side. And oftentimes we lay that hallux, that short number 1 toe, flat against the surface. This guy's got 2 toes forward here. He's swung around number 4, and it's a little hard to see, but he's got his hallux flat against the tree. Now, I want you to watch this Harry's foot. I'm going to show you some different poses, and notice how the toe, that outer toe, is adaptable for different postures on the surface. So it can swing it around so that there are 3 toes forward, and that hallux, again, is laid flat against the tree. Is that a zygodactyl toe formation? No, it's not. Okay, and when we talk about the form of organisms, we talk about the function, right? Form follows function. And so you spend more of your life climbing, then you have something different to facilitate that. And again, you can see that depending on where the bird is on that's actually a signpost, a square 4x4 signpost. Depending on where the bird is, it's going to move those toes around to get it the best stability. All right. Feathers of woodpeckers. Just a couple of things to highlight in feathers. This is a handful of baby red-cockaded woodpeckers. We banned every single red-cockaded woodpecker in the world. It's hard to imagine, but we know where every red-cockaded woodpecker is because it's an endangered species and we have a lot of money to study them. And so we have biologists. It's one of the biggest biology jobs out there is to study red-cockaded woodpeckers. Sage grouse are getting popular now for scientific study, again, because of the threatened status. But in general, the red-cockaded has been endangered quite a while, and we've been learning a lot. So one thing that we learn about woodpeckers by looking at these babies is something that they're missing. What would that be? What kind of feathers are they missing? Down. There's no down. Okay? These birds have already had, have already had their main feather eruptions. You can see the little shafts of those feathers coming out. Woodpeckers do not have down. None of them do. Okay? Babies or adults. And this is, it takes a lot of energy to grow feathers. And if you've got a whole different layer of feathers, that's going to take a whole additional set of energy or amount of energy for you to develop those. Woodpeckers spend most nights roosting as well as nesting inside insulated cavities. So they don't need the insulating layer of down. Okay? So it was more efficient for them to have contour feathers and flight feathers that allow them to kind of encase their body to regulate their own temperatures. Thermoregulate, we call that. The other fascinating part of woodpeckers' feathering is this tail. And I mentioned this a little bit earlier. And this is a great example of how that tail is propped up against the tree. And those feathers are very specialized. You can see they taper toward the tips, and they have a very strong rachis, R-A-C-H-I-S. That's the shaft of the feather. So that when they push that tail against the tree, those feathers are very stiff. Then they have those feathers attached to those specialized muscles that then attach to the pygostyle, which allow the bird to push so that it can rear back again and deliver those blows of 1,200 Gs. Okay? Everybody got all that? So woodpeckers are cool, right? I mean, we agree. I think we can agree on that. Woodpeckers are cool. So what? Lots of birds are cool, right? Hummingbirds are cool. Hornbills are cool. Everybody's got their favorite family of birds. But woodpeckers are super cool. Beyond our fascination with woodpeckers, they play key roles in our forests and woodlands. Okay? And this is where we come to ecology. Ecology is how organisms interact with their environment. The crux of the woodpecker's ecology is based on this arch. Okay? You recognize this as an arch, correct? Thank you. And the keystone, okay, is the center stone in the arch. What happens if you take the keystone out? The arch can collapse. Okay, in biology, we have a term called keystone species or keystone organism. What is a keystone species? Keystone species is one that has a disproportionately large effect on its environment relative to its abundance. Think about that for a second. So a large effect for a small number of birds. So a small number of woodpeckers can have a large impact on their habitats. Put a different way, keystones are species on which other species depend, so that if you took them out of that habitat, those ecosystems would change drastically. Okay? Woodpeckers are keystone organisms everywhere where they live, in all of the habitats they occupy. They have several keystone roles. Some of them are secondary. I'll show you a couple of those. One of them is the excavation of sap wells. The red-naped sapsucker is fairly highly migratory, and the yellow-bellied, as you know, is highly migratory. When the red-naped and yellow-bellied sapsuckers and the Williamson sapsuckers are migrating north in the spring, hummingbirds follow them north on their migration and feed on the sap wells before all of the plants and shrubs and other forbs have started blooming to provide their nectar food. So these hummingbirds have developed their migratory patterns based on those of the sapsuckers. Another keystone role played by woodpeckers has to do with this beautiful looking guy here. This is a western-eyed elater. Cool name. The family of beetle is the Elateridae, and his larvae, or her larvae as I should say, She's laying eggs here in the bark of the tree. Her larvae are going to bore into the wood of the tree, and they depredate the larvae of other wood-boring beetles. That's a cool adaptation. This beetle's about 2 inches. Pretty good-sized beetle. And they're fairly common. And especially if you go into a burned forest, you just keep your eyes open for them. They're real easy to see when they're flying because they're big. And you can even hear them flying because they're large. They have large wings, and they'll land up against a tree like this and lay their eggs in the bark. So woodpeckers then feed on those wood-boring larvae, not just from the elater, but from the cerambicid beetles and the buprestid beetles. The cerambicid beetles are the longhorns beetles. The buprestids, we have several different kinds, pine borers and others. And woodpeckers are feeding on those larvae. And there have been studies that show that woodpeckers can consume up to 2/3 of the larvae in an infested stand of trees. Okay, that's a profound impact on that forest. And in a sense, it delays the decay of those trees. Okay, the more larvae that are in a tree, the faster that tree is going to decay and snap off. Woodpeckers, by excavating those larvae out of there, provide their own food and then actually prolong the lifetime of some of those snags. But how can woodpeckers save the world? Well, let's back off from hyperbole and focus on how woodpeckers can save our local forests and woodlands, okay? What is the woodpecker's primary keystone role? Well, it has to do with this bird, the wood duck, the American kestrel, mountain bluebird, the little flammulated owl, and the oak titmouse. What is the connection? Cavity nesters need woodpeckers. There are more than 40 species of birds in North America, not counting the woodpeckers themselves, that depend upon woodpeckers to excavate their nest cavities. If the woodpeckers were taken out of those ecosystems, these birds would not have a place to nest. They have evolved nesting in cavities. Okay? So the woodpecker's primary keystone role involves the excavation of these cavities. Okay? But we have an ecological conundrum. Humans need habitat too. I don't think any of you would deny that. Okay? We need our own habitats. And so we've had a profound impact on our forests and woodlands. We plant trees in our neighborhoods, as you can see down in here. And we like the greenery, and it's good for the atmosphere. But there are other unintended consequences involved with this kind of development. One of the things that we need in order to create our habitats is our wood products. How many of you used a wood product today? I know you don't all have to raise your hand, so I'll raise one hand for each of you because I'm willing to bet each of you used a wood product today. Okay, because we need wood products, we have transformed our forests into plantations. They are even-aged stands of timber that are no longer functioning as a normal ecosystem. To be sure, there are organisms that thrive in these kinds of even-aged stands of trees, but they're no longer functioning in the way that that ecosystem existed before we went in and took those trees out. There are huge swaths of forest land all over, especially in the west, but definitely in the southeast, other parts of the country, where we've created these monocultures. You've heard that term before. Monocultures of trees to supply wood products. So we grow and plant trees for that purpose. We also tend to go into burned forests and take those trees out. Once in a while, we'll leave a couple in the middle of a stand like this. This one here has an orange W painted on it. It stands for wildlife. Those are wildlife trees. It's pretty silly, I think. if we're going to leave trees standing like this, leave snags standing, I think we ought to do it near the edge of the stand instead of out in the middle. Those trees are going to come down in the first winter. And we tend to take all of the timber out of these burned areas. We call this post-fire salvage logging. And California has a particularly big challenge managing post-fire salvage logging and its impacts in the forest. In bug-killed forests, we do the same thing. You can see that all of the dead trees have been taken out of this lodgepole forest, and you can see them stacked up here. And so this is no longer functioning in the same way that it did before this occurred. Bug kills are natural. The bugs are natural. There are some cases where there are beetles that have been imported from Asia through in wood products that have been brought from Asia or Europe. But many and most, I would say, of the beetle larvae that are in our trees are native. And their behavior is simply taking advantage of a situation we've created. Okay? Don't blame the beetles. Okay? They're just doing their thing. They're really good at what they do. Okay? Think about you and your career. You're really good at what you do, you know? Nobody would blame you for that. Beetles do the same thing. Their job is to go into these trees. When we cut these trees, we also tend to cut them at their bases, which leaves very little in the way of habitat. And the result? Something is missing that is preventing the woodpeckers from doing their jobs. In all those habitat pictures I showed, what was missing? Cavity dwellers need woodpeckers, and woodpeckers need snags. Most woodpeckers are not heavy-duty excavators. Okay? There are several that are, and we talked about those, but all woodpeckers nest in cavities. Some of the weaker excavators will take a cavity that was excavated by, say, a hairy or a blackback and expand it and then reuse it in the following season. But in general, they all need snags because these are easier to excavate. You're not going to excavate a cavity in a live pine tree. And we're not going to go into red-cockaded woodpecker ecology tonight. They excavate in live pine trees, but that's a very specialized bird, and it's part of the reason why it's endangered. But except for the red-cockaded, most of the time, especially in conifer trees, we don't excavate in them because the sap is going to keep filling up that hole and make it impossible for you to excavate the cavity. In aspen trees and some other similar related trees, they get heart rot when they get older, and so it's a little easier to excavate through the outer layer. So that's one case where live trees are still beneficial. But in general, we need snags. Okay? A healthy forest has seedlings, saplings, small, medium, and large trees, mature trees that have reached the end of their life, and snags, both standing snags and downwood snags. Okay? That's a healthy forest or a healthy woodland. It's got to have all those different age classes. So there are a few things that we can do to reach that state once again. Snag retention is the first thing that we should consider. When we have a burned forest, it's very important to not go in and immediately salvage those trees. The blackbacks especially, but also the other birds in its genus, the woodpeckers in its genus, like the white-headed, hairy, downy, and a couple others, they will go into these trees and feed on those wood-boring beetle larvae. When the fire is occurring, the beetles will fly into the forest. They will, while the trees are still smoking, they'll fly in, lay their eggs in the bark of the tree. Their larvae will hatch and bore into the tree, either behind the bark for bark beetles or into the wood of the tree for wood borers. The bark beetles tend to leave after about a year. They pupate and emerge as adults after about a year. The wood borers, however, can take up to 4 years to go through all of their molts or instars and pupate and then emerge as adults. So those first 4 years are critical for snag retention in burned forests, especially for the blackback and hairy and some of the others in that Dryobides genus. So snag retention in a burned forest is especially important and something that we need to pay attention to here in California. But it doesn't just happen in burned forests. When we have snags, we can just leave them standing. And it's about changing how we look at a forest. It's about changing the paradigm. What does a healthy forest look like? You know, most people would think a healthy forest looks like a bunch of live green trees. But that's not true, remember? A healthy forest has a broad succession of age classes, right? And so that includes snags. So here's a relatively healthy live forest. It's got multiple different age classes with a beautiful snag standing. Okay, that's just one example. Even in our urban environments, this picture's taken in Bend, right on the Deschutes River, where I live. Even in our urban environments, we can leave snags standing. We can top them. These trees have been topped to minimize the safety risk of having those trees fall on people recreating. Okay? Obviously, there are safety issues. You don't want a tree to fall on your house, right? A dead tree. Maybe your homeowners association says you're not allowed to have dead trees because they're ugly, right? We need to change the way we look at forests and woodlands. We need to be thinking about this broad succession, okay? These trees got topped, and the woodpeckers were using them the first year after that happened. But we don't have to go to the expense and the trouble of topping them that tall. Trees can be topped at just 6 feet. And this was an active flicker nest in this tree. So when we're cutting our trees, I showed you one that was cut at the base, right? We've lost pretty much all of the cavity use of that tree. Here, we left 6 feet, and we've got one cavity, and I can bet you I go back there in successive years and find more cavities in that one little stump left standing. Okay, in addition to snag retention, we can practice snag recruitment. That's kind of a strange term, I know. So back to our neighborhoods and our homeowners association. You know, we love our green, pretty trees in our urban environments. And I'm not opposed to having green trees. And there are whole organizations that are dedicated to planting trees. And planting trees is a good thing. We need live trees, especially in places where we've taken them out. But a whole bunch of live trees is not a healthy woodland or forest, right? There has to be diversity of age classes. So one way we can do that is we can speed up the decay process by girdling trees. That's just one way of doing it. We can also go into these trees and top and limb them, and this will facilitate decay. We can also drill holes in them and insert fungal spores. This is done quite a bit, actually, especially in the national forest. This will speed up the decay of the trees. So recruiting snags is another piece of that puzzle. But I've already alluded to this. I've already said it word for word. The number one solution to restoring our forest is to restore and conserve a broad succession of age classes. A forest that has a single age stand is not a healthy forest. An aspen stand like this that's got tiny aspens down here, small aspens, medium-sized aspens, and large aspens is a healthy stand of trees, okay? In our conifer forest, you can see a stand like this that's got large trees, nice big snags standing, and lots of small trees, as well as large down trees, all providing habitat. Even in urban woodlands, this is in Sacramento, we have a broad succession of age classes. This is a preserve. I don't remember the name of it. Some of you might know it. It's where the Sacramento Audubon does their talks. There you go. And that park has been, had a lot of attention's been paid to that park to restore the habitat there. So they've got large oak trees, smaller oak trees. They've got standing snags that they've topped to minimize the safety risk. Other snags that they've left standing when they're not too close to the trails. And they're planting. You can see this tree here that's got a cage around it to try to get the seedlings and the saplings going to, again, create that broad succession of age classes. So, what can you do? I know you're jazzed now. You know that you can help. The first thing you can do is join your local Audubon chapter. Even if your Audubon chapter isn't doing something directly related to snag conservation, they are doing conservation work in your community that is conserving healthy habitats. And maybe they are working on snag habitats, and they then need your help. Whether you're just joining, paying a membership dues, or whether you get involved as a volunteer or work on the board, these Audubon chapters are a really important part of our local conservation of forests and woodlands in our local communities. Another thing you can do is support the science. Institute for Bird Populations is a fabulous organization, and they are doing the science that's necessary out there to show us what needs to be done for conservation of habitats. They're very good at it, and their data are used by all the public agencies as well as other management agencies that are also working to restore and conserve healthy forests and woodlands. You can take this the next step, and you can get involved with this organization, the Cavity Conservation Initiative. And boy, I wish Jillian Martin could have been here tonight. She's from Orange County, and this project was started by her as part of the Southern California Bluebird Club. Jillian single-handedly, Jillian's retired, does this all pretty much by herself, single-handedly has changed the best management practices for the West Coast Arborist Society so that they are leaving snags standing. She's changed the best management practices for the Orange County Parks Department. And she goes into schools and teaches kids about snags and what snags do for the environment and what a healthy forest or woodland looks like. And I encourage you to go to the website, check it out. If you're involved with kids at all, there's information, there are things you can download there, worksheets and stuff that are really simple to use and easy to interpret, and lots of great information. And if you are really into this, if you're really jazzed after tonight, you could get in touch with Jillian and you can help implement similar type projects here in the community here in San Luis Obispo County. So, by conserving and fostering healthy forests, we can help woodpeckers maintain their keystone roles, and especially the excavation of those nest cavities. And we do this for the woodpeckers as well as all the other cavity nesters. Thank you. Thank you very much. Wow. Thank you. Thank you so much. I am so honored. I'm really touched. I really appreciate it. I think that we would like to, do we have time for a few questions? Yeah, we have a couple of microphones set up at the corners over here by the exits, and either you could come down here or Chris could help us out and you could relay your questions, but I might even be able to hear you if you just want to shout it out to me. Go ahead.
Well, I'm wondering, given that the monoculture is one of the problems that you're highlighting, have you worked at all with the paper and wood company company organizations to help them figure out, how better to harvest efficiently? Because it's the efficiency of harvest that's driving the monoculture. So they have to figure out a different way of managing and harvesting that's, nearly as efficient in order to be competitive. So any progress on that front?
The best progress we can make on that front is to look at private timberlands differently from public timberlands. Okay? Most of the wood products, most of the trees that are sources for our wood products are coming from private timberlands. We don't need to be utilizing our public lands the same way we're doing with the private lands. We need to conserve wood use, wood products, right? We can have some impact on that, decreasing the need for wood products, but it's going to be really hard to go to private landowners and tell them how to manage their land. So we kind of veer our focus toward the public lands. We are able, as the public, to tell our public agencies how we want those lands managed. And so that's kind of where the energy gets focused. It's going to be, it's going to be we may never get away from using wood products. And if we're going to use wood products, let's use the private lands to develop those trees. That's the best thing I think that we can do. Anybody else? Yeah, right down here.
So bouncing off of that question, how as like a consumer can we try and
Here's the microphone.
how as a consumer can we make sure that we're like consuming like sustainably and like yeah.
How can we consume sustainably? The best thing that we can do to consume sustainably is minimize consumption. Recycling is great, but it can be a panacea sometimes. We buy stuff and say, oh, I can recycle that, right? And I'm not anti-recycling. I recycle. But it's important for us to think that the input solution to that problem, recycling is an output solution. The input solution to that problem is minimizing the consumption in the first place. So that's the first thing, is to look at wood products that you're using and try to minimize the use or decrease your use. One of the best things that we've done on that front is I don't know what that was. One of the best things we've done is we've developed artificial wood. So building decking materials, park benches, and things like this are being done now with artificial wood made from recycled plastic. So that's one really creative way that we can minimize wood products. How about building hay bale houses? You know, I mean, that's kind of extreme. I don't expect all of you to go out and build a hay bale house or a straw bale house. But ideas like that are important. Creating different ways of building the structures that we're using, where we're using the wood products is one big thing we can do. We can also educate ourselves. Figure out how wood products are being used and where that wood is coming from. Learn in your state in particular, and actually you can contact your Forest Service probably, or your university extension offices to learn more about where the wood is coming from and what the different types of trees are being used for. So, you know, learn like what's Douglas fir being used for in your region, or what is pine being used for in your region, or whatever the other types of trees are. Another thing that we're doing is using these wood products for energy generation now, which is a decent source of alternative energy. You know, almost none of these alternative energy sources are 100% positive. But in places where we have, you know, downed wood, or we have to cut trees, and we don't have a use for them as a normal wood product, we're kind of focusing some of that energy on creating energy. Anybody else? Yeah, over here. Go ahead.
Can you hear me?
Yeah,
Well, first off, amazing presentation. That was excellent.
thank you.
So I was curious about fire suppression regimes in the West and how that relates to boring and bark beetle populations, and then that whole dynamic between over-infestation of forest systems and then obviously woodpecker consumption, that dynamic.
Well, I'll give you the short answer. That's another lecture. And it's a big can of worms, and I'm sure you already knew that. But I'll give you the short answer, and that is we've altered the ecology of the forest by suppressing fire. We can't just let fires burn anymore because we live in the forest and the trees have timber value. Okay, so we have to put these fires out. The alternative there is to manage the forest differently so that they're healthy forests. But the beetles in particular are going to thrive in an unhealthy forest. The wood borers aren't going to go into live trees. They need dead and dying trees. That's because their larvae are chewing through the live wood. If it's a live conifer, that larvae is going to drown. Okay, so they're mostly focusing on dead and dying trees. The bark beetles are the ones that tend to get the worst reputation. They're the ones that can go into live trees and cause the bark to come off the tree and girdle it and basically kill the tree. The bark beetles are taking major advantage of this. And this is one of the reasons we go in and do some thinning projects, like you saw one of the thinning projects I had in one of the slides. We're then looking at a situation like a boom and bust, where we're going to have a lot of food for woodpeckers. So we're going to have a lot of woodpecker babies for certain periods. And then after these big catastrophic fires, those trees are going to be great for a while, and then they're going to come down. And then we're going to have a bust cycle. So we've totally altered the ecological processes, and I think the best thing we can do now is to reassess how we manage the forests and look at the conservation of a broad succession of age classes. And when we're cutting trees, selectively cut, when we've got bug-infested forests, leave some of those trees standing. Because once the bark beetles kill a tree, then the wood borers get in there and they provide food, and then those trees become cavity trees. So the beetles, in a sense, can thrive in an altered situation like that. And we just need to look at how we manage the forest to take advantage of the beetles, but also move toward healthier forests. Yes?
I've occasionally noticed lately, I'm in Marin County, I see some hairy woodpeckers with yellow tail feathers. Is that fairly common, or what's the deal there?
It's more common than you would think. Actually, there was a paper written in the Western Field Ornithologist Journal a little while back about that. And there is an occurrence of, sometimes called xanthocroism. Xantho meaning yellow. You know the bird xanthocephalus? Yellow-headed blackbird, good. So xantho means yellow. Xanthocroism is going to be the expression of yellow pigments. And so sometimes we get selective xanthocroism where hares are expressing some carotenoid pigmentation in their outer tail feathers. So it does occur, it's rare, but it's pretty well known and fairly widespread. And you probably didn't notice, but the very beginning I had a hairy woodpecker that was atop a frozen tree, and he had some of those yellow outer tail feathers too. So it does happen, yep.
I have a quick question
Yep.
about the snag recruitment.
Yep.
So if you're cutting down a tree, you leave it 6 feet or more. Is that for any kind of tree, or is that just for a conifer or a barky kind of tree? Or is that any tree could be used for snag creation?
I think any tree that you're either a live tree that you have to remove or a snag that has to be topped should be left as high as you can stand it, right? You have to minimize your safety risk. And I don't blame you for not wanting a tree to fall on your house or your kids, right? I mean, we can be reasonable with this. I like to think of 6 feet as kind of the starting point. And as far as the species of trees, conifers tend to rot pretty quickly, and so they provide habitat relatively quickly, snag habitat. If you do oak trees, they take a little longer to rot. But if you're talking about a big oak tree that's already dead, it has heart rot. Almost all large, mature oak trees have heart rot. And you'll often see woodpeckers nesting in the broken off branch stubs of big live oak trees because those snags, or those snaggy branches, whatever they are, have rotted out on the inside, so they're easy to excavate. So I think any tree that you have to top or have to girdle is going to have some benefit. It just might take longer depending on the type of tree that it is. Yeah.
Okay.
Anybody else?
Two more questions.
Okay, 2 more questions. Dos más. Anybody else? Yes. Hang on just a sec. Microphone's coming.
Close to your mouth.
You said that most woodpeckers don't have down feathers. Is that all of them, including woodpeckers that are in like way northern latitudes, like up in the Arctic and stuff as well?
Woodpeckers do not grow down.
The downy woodpeckers?
Nope. No down. The downy is his species name is pubescens, and he's kind of called. One of the reasons he's called downy is because down is considered something associated with a young organism, a young bird, and so he's called downy woodpecker. But he doesn't have any down. None of the woodpeckers do. I've read before that some scientists have found Lewis's woodpeckers that they think are exhibiting some like similar down feathers, but in general, all woodpeckers lack down. Okay, one more. Over here.
now we have two more because we got one here and one there.
Okay, two more.
You're the last.
I have a question about urbanization of woodpeckers.
Yep.
How urbanized are like the big cities, San Francisco, Los Angeles? How urbanized are woodpeckers in those areas, and would tapping trees and that stuff really help?
It would have a major impact in enhancing the habitat. The Nuttall's woodpeckers were almost extirpated from San Francisco. But recently, they've been reported nesting, I think the last I heard was in the Presidio area. So in any of our urban parks, we can practice these types of forest management to facilitate the use of those trees by woodpeckers and to support their local populations, which then is going to support bluebirds, wrens, chickadees, all the other birds that make a healthy habitat in our parks. It's hard to think about managing like street side trees, the trees that just line your streets. That's a little different. So focusing on public park areas is probably the best way to do that. A lot of agencies have also worked on green space connections, so green belts, connecting the parks with green areas. So working within those connector belts is another way to enhance that habitat to allow the movement of the birds. So you might have a big park that's got a good, robust woodpecker population, and they don't have anywhere to go. So let's create a pathway for them to get to some of the smaller city parks by enhancing the snag habitat in those areas.
Okay, our last question back here.
In the back.
Has there ever been any effort at looking at artificial nest boxes for these birds in any of the forests?
Yeah, great question, and this is a great place to wrap up. Most woodpeckers use excavating the nest cavity as part of their courtship ritual. Okay? So they need to excavate. So a bird box does not suit most woodpeckers. However, the bird that will most readily take to a nest box is the same bird that is the biggest culprit of excavating in our buildings. Northern flicker. Okay, flickers will take to a nest box like that. Okay, and flickers, because of their abundance and their ubiquity, are the number one culprit of making holes in your houses. Okay, they're a weak excavator. Remember that. They're a weak excavator, so they go up to your house and they find a nice hollow piece of wood, right? So they excavate a hole, and then they look inside, and it's not what they thought. So they move over 3 feet. And do it again and again and again. And people pay thousands of dollars to repair woodpecker damage. Okay, that's another subject. We can do other things to deter them, but the number one thing we can do to deter flickers from excavating in their houses is put up nest boxes. Okay, flickers will take to a nest box right away. So I'm a big advocate of that. Go online, look at the plans if you want to make your own. There are lots of schematics and plans for building your own boxes, or go to your local Wild Birds Unlimited or Wild Bird Center or whatever your backyard bird store is and buy a flicker box. They will often have those in stock. Now, there are scant few, pardon me? Well, that's a different story. Those red-cocked katydids nest in inserts. So they make boxes for red-cocked katydids, but they take a chainsaw and cut a hole in the tree and insert the box. And then put wood putty to make it look like it's part of the tree. So that's a little different. Different story. So the woodpecker doesn't recognize it as a box. It recognizes it as a cavity, and they'll use it. The other bird that does rarely nest in boxes is the Nuttall's. We have a couple of records of Nuttall's. Now, a lot of woodpeckers roost in boxes. So the boxes can still be beneficial, and these can be smaller boxes. And woodpeckers will open up a bluebird box sometimes by hack. You've probably seen that if you do bluebird box trails. They'll hack around the outside edge of the opening and make it bigger, and they'll roost in there. Bluebird biologists see Nuttall's roosting in their boxes all the time. So they kind of are rare to nest there. The other birds that will occasionally take to artificial nest structures are acorn, Lewis, and redhead. These are also weak excavators like the flicker. And so they are often just very opportunistic and will take advantage of an artificial box. Most of the boxes that have been made for them have been kind of fake-looking trees. They're like rounded or hexagonal shaped. But in Central Oregon, the Audubon Society there has successfully gotten Lewis's woodpeckers to nest in boxes for the first time. And so they are using basically a flicker box. And they put these boxes out in areas where the populations are dwindling of Lewis's. And now this is being used as a conservation measure, if only a stopgap measure, to help conserve the tenuous populations of Lewis's woodpeckers. I say it's a stopgap because it's an output solution, right? The input solution is to create more snags, right? For bluebirds, same story. I'm all for these great volunteer bluebird projects, but I also want, while we're supporting the bluebird populations with artificial boxes, I want us to be thinking about the input solution at the same time. So this is where the Cavity Conservation Initiative came in. Jillian, who started the project, was an avid bluebird volunteer, and she started asking the question, shouldn't we be doing something to have natural cavities for these bluebirds? Why are we using the boxes so much? And it was partly because her group of bluebird volunteers is an aging group of people, and they didn't have recruitment of young people coming in to help monitor and manage the bluebird boxes. So eventually those boxes are going to not be used, not be managed or maintained. So the long-term solution is still broad succession of age classes, managing snags and retaining and recruiting snags in our forests and woodlands. Thank you very much.